So in this video, we're going to go through the 2.2 graphing piecewise functions. And the best way to think about piecewise functions is to first analyze different pieces and put limits on them. And when I say put limits on them, I mean restrict their domain. And the domain are the x values. So look at our first graph. It says x plus 2. So if you were to graph this, what you should do, it's a graph of a line. So figure out your initial value, which is 2. So that's right here. And then your slope is 1, because that's the coefficient to the x. So you're going to go up 1 over 1, up 1 over 1, up 1 over 1. That's the pattern. Then use your straight line tool, and we can get a nice straight line and put arrows on both ends because this line continues unabated in both directions, as opposed to this next line. Now, what I would suggest you do is get in the habit of doing little t-tables. So a little t-table is named because of the letter T that you initially have. So this is going to be your x, this is going to be your y. Whatever the limit is, this is your restriction. Start there. Even though it says x has to be less than 0, start with 0. And then you would say -1, -2, and I'm going to indicate that I'm going to go on forever and ever in that direction of getting less than 0. So if x is 0, I plug it in over here. So my y is 2. If x is -1, my y is 1. If x is -2, my y is 0. Because I can't equal x is 0, I'm going to write the word open right here so that I know that when I plot this point, it's going to be an open circle. Okay, at this point, I'm going to plot. So again, the initial point is where x is 0 and y is 2. But I'm going to put an open circle there because there's a hole there. Your function cannot equal 0. But it gets so close to it that we represent it as a hole in this way. Then I have -1 and 1, -2 and 0, and I can see the pattern developing. It's the same line I graphed in the other window, but with a restriction built in. So I need only one arrowhead. I don't like it going that way. So we'll see if we can turn this around. Not really. Well, so let me get rid of that. Let me get rid of that and write my own arrowhead in. Okay, so that's the restricted line. Okay, let's keep going. Now we have a horizontal line. So the horizontal line, unrestricted, is to the left, and y equals 4. So you should go up to 4. 1, 2, 3, 4. And you've got this nice horizontal line with arrowheads on both sides. Okay, now look at this. I have a restriction. So I'm going to use my t-table to get my values. Okay, this is your x and your y. Okay, so my restrictions are at 0 and 2. I'm going to use those points as my points I'm going to evaluate. So, and I'm going to write that this is closed and closed here because it's not a strict, it's closed in the first one, but it's open in the next one because the last one at 2 is a strict inequality. See that? So take note of that, because if it's less than or equal to, you get to put a closed circle. If it's less than, you get to put an open circle. Okay, so let's do our evaluation. No matter what the value of x is, y is constantly 4. So be comfortable with that. And now let's plot what we have. So this line is very limited. So at 0, we go up to 4. 1, 2, 3, 4, and that's a filled in dot. Then 1 is fine. And at 2, we're going to have an open circle. So connect the dots, and that's what that looks like. Okay? So that's restricted. Here's another line. It has a different slope than the first line we did. So the slope is 2. The initial point is -5, so go down to -5. 1, 2, 3, 4, 5. And I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. That gives me the pattern of my graph. So now I'm going to connect the dots. Use the straight line function or feature of your iPad. And I get a nice line that continues in both directions. Same line, but with restrictions for this last one. So get your t-table going. My t-table tells me that this is going to be in play when x is greater than 2. So you're going to start at 2. And at 2, I know that my point will be open because x has to be greater than 2. So 2, 3, 4, and then this can continue on because there's no limit placed on it. So if x is 2, 2 times 2 is 4, 4 minus 5 is a -1. If x is 3, 3 times 2 is 6, and 6 minus 5 is a +1. If x is 4, 4 times 2 is 8, minus 5 is 3. So those are the points I'm going to plot. So at x is 2, I'm going to go down to -1, but I'm going to do an open circle. X is 3, I'm going to go up to 1. X is 4, I'm going to go up to 3. And that's the pattern. Get your line tool and do an arrowhead, and we have that restricted line. Okay, so that's the restrictions. Now let's apply this knowledge to several piecewise functions. So when you look at piecewise functions, you see that you have one function right here, but it's just in 3 different pieces, thus the name piecewise. So what I'm going to do is do it using different colors, and I would really strongly advocate for you to do the same. So I'm going to have the first piece be green. That piece is in effect whenever x is less than 0. Come over here to the evaluate, and when I evaluate f of -1, I'm going to use the green piece. Then go on to f of x equals 4 during a certain window. Okay, that window is from 0 to 2, not inclusive. 0 is included, but 2 is not. So I'm going to change my color for that to red. And I'm going to evaluate here using that piece, so that section of this function, because that qualifies. 2 does not qualify. So let's change colors one more time. Blue. And for this piece of the function, these 2 evaluations will apply because for both of them, x is greater than or equal to 2. Okay, so let's start doing some evaluations over here. If I plug in a -1 for here, I get -1 plus 2 is a 1. So that should be a 1. Let me write that a little nicer. That's a 1. Then go down, I'm going to change to my red and plug in 0 for the second piece. No matter what the x value for the second piece of the function, the y value will always be 4. Okay, change to your blue color. And for the last piece, plug in a 2. 2 times 2 is 4 minus 5, gives you a -1 for the evaluation where x is 2. And for the evaluation where f is 4, or where x is 4, you're going to plug in a 4. 4 times 2 is 8, minus 5 is 3. Okay, so that takes care of the evaluate box. Now let's go back to our green color again. And what I would suggest that you do is do some interval notation, do some t-tables, and I'm going to do them color-coded. Okay, so here's my first one that goes with the green parsed piece of the function. And I'm going to do an x and a y. And this says x has to be less than 0. So I'm going to start with 0. That is really critically important. Start with 0 and I'm going to say that this is going to be open there. So write the word open there. Then I'm going to go to numbers less than 0, so -1, -2, and I'm going to put an arrow so that I know that I'm continuing on beyond that. So let's get some values. Plugging in a 0, I get 2. Plugging in a -1, I get 1. Plugging in a -2, I get 0. Let's go over to our graph and plot those. So if x is 0, y is 2, and that's going to be an open circle. If x is -1, y is 1. If x is -2, y is 0. And I see the pattern, and it's going to continue this way. And that is that piece of the function. Okay, so you should be thinking back on the previous page, because this work is going to be very familiar. But we're putting everything as one function on this piecewise graph. Okay, I'm going to turn my color now to red. And let's get a t-table for the little red section, which is pretty basic, because what's happening there is for every value I get 4s. So I'm going to pick 0, 1, and 2. And this is going to be closed right here and open right here because of the inequalities that are present. But every single y value will be 4. Let's go ahead and graph that. So my first one is 0, 4. So I'm up 2, 3, 4. That's going to be closed. Then I have 1, 4. And I have 2, 4. But that's open. So this is the extent of that piece of the function. Just that little piece right there. Okay, let's change to blue. And for blue, what I have is a need for a little t-table. So here's the t-table. And these numbers are going to be 2 and greater. 2, 3, 4. That's plenty. This is going to be closed at 2. And if I put a 2 in, I get 4 minus 5 is a -1. If I put a 3 in, I get 6 minus 5 is a +1. I put 4 in. 4 times 2 is 8. 8 minus 5 is 3. Okay, and these match some of the figures I've already evaluated in that little box. So let's graph these. So if x is 2, y is -1, and that's closed. See how that's filled in now? So I have an open circle above it, closed below it, so it's still a function. It doesn't violate the vertical line test, and I'm good to go. Okay, then I have 3 and 1, and I have 4 and 3. And does this end or does this continue? This continues, so I'm going to put an arrow there to remind myself. And then when I draw this in, I'm going to keep going with an arrow right there. Okay, so that function is now graphed. Now, I'm changing my color to black because I'm evaluating the domain of the entire function. So start at your lowest x. That's going to be related to the arrowhead to the furthest left in the green part. That's going to make my x's go to -infinity. And I'm following along, and I'm hopping on the curve. So what I'm doing is this. Let's see if I can do this. Okay, I'm trying to figure out my x's. So I follow along. I get to here, and I say, oh, do I have a gap? But I don't, because I can jump up here. I can continue this way. Oh, do I have a gap? No, I don't, because I can fall down here, and I can continue going this way forever and ever. So that's why my domain is -infinity to +infinity. Now let's evaluate our range in the same way. Okay, my lowest number I get to is here. I'm now going up the curve. I can go up this way. Up, do I get stuck? No, I don't, because I can hop up here. I can still continue to go up. Up, I'm going to go temporarily down, but can I continue to go up now? And now when I go up, I'm going higher and higher on y's. There was no gap because the gaps were filled in by other pieces. So my range is also -infinity to +infinity. Okay, so that's one down. Let's look at another one. Well, first we're going to do this practice. So let's do some line practice. It's a little bit more complicated lines, and we introduce a parabola. Okay, so practice 2. So I'm going to change my color. So this is 2x plus 3. Get this value, 1, 2, 3. Rise up 2 over 1, up 2 over 1. You can see the direction your line's going in. Get yourself a line with 2 arrowheads indicating there's no restrictions. This one we're going to do a little t-table, because that's what we do when we have our piecewise functions and we have restrictions here, and there are restrictions on piecewise functions. So if x is less than 0, don't forget you're always going to start at the first value they give you, even though it has to be less than. So I'm going to go to 0, and I'm going to go -1, -2, because it's going less. And I'm going to give myself an arrow because it's going on forever and ever. And I'm going to say that this is an open circle right here. Now plug in. I get a 3. I get a 1. Hold on a second. So -1 times 2, I get a +1. I get a -1 here. So just check my math. It should be okay. Plot those points. I start out, x is 0, y is 3. I have an open circle. Then I'm going to -1 for x and +1 for y, -2 for x and -1 for y. I see my pattern developing. Use your line feature. There you go. And that's your graph. Okay, parabola. First time doing a parabola. So let's do this carefully. So come over here, and I'm looking at parabola. So I happen to know that this is a transform parabola. It starts here. I'm going to plug in some numbers. If I plug in a 1, I get a 1. Whoops. Yeah, I get a 1 plus 1 back. If I plug in a -1, I get the same thing. If I plug in a 2, I get 4 plus 1, which is 5. 1, 2, 3, 4, 5. Do the same thing over here. You get 5. And that's your unbounded parabola. It's going to go forever and ever up this way. Let's restrict the parabola. So whenever I restrict anything, I tend to do a formal t-table so that I can be more focused on the values I really need. And so remember, always, always, always use what they give you and indicate whether it's open or closed. So here is my 0, my 1, and my 2. This is closed. This is open. Plug in a 0. You get 0 squared plus 1 is 1. Plug in a 1. You get 1 plus 1 is 2. And you get 5 here. Okay, so now let's go ahead and plot that. At when x is, this is x, this is y. When x is 0 and y is 1, that is going to be a closed circle, because you're allowed to equal that. When x is 1 and y is 2, that's going to be a closed circle. But then when x is 2 and y is 5, that's your open circle. So you can see how you have to capture the curve. It's not a straight line this time. It's a curve because it's a parabola. So be careful about capturing the curve. Okay, we have another line to do. It's horizontal. So let's look at that. Y is 5. 1, 2, 3, 4, 5. It is this line right here. Okay, there you go. And here's a restriction. So I need my little t-table. And this is my x, this is my y. So this says x has to be greater than 5. So always start at the 5 and then go greater. And tell yourself you're going greater. It's always going to be 5 for y. And this is going to be an open circle. So when I go over 5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, it's an open circle. And as I go further and further to the right, I can put an arrowhead on there and I am good to go. Okay? So this should give you an idea about what's coming next, which is more piecewise functions. So look, we're going to evaluate this piecewise function. And we have a parabola in the middle of it. So that you should have probably seen coming. So let's talk about this one. So when I look at this, let's start out using blue. If x is less than 0, this is going to qualify. Then we'll change to red. If x is between 0 and 2, I'm going to use red. Okay, so those two can be red. And then we'll go back to green. If x is greater than 5, I'm going to use it right there. Okay, so let's see what we have for these evaluation numbers. Go back to my blue. If x is less than 0, I'm going to use that when when I'm evaluating the function at -1. Because remember, these are your x values. So I plug in -1 to the first piece of the function, and I get 2 times -1 is -2. And -2 plus 3 is +1. So here's 1. Now let's change to red and plug in 0. And which piece am I using? I'm using the second piece, the red piece. So 0 squared is 0 plus 1 is 1. Plug in a 1, the same red piece. 1 squared plus 1 is 2. And now I'm going to change to green. And f of 6 is going to use the green piece, and no matter what the x value is for the green piece, the y is always 5. Okay? So now we have some idea about evaluations. We are now going to graph this as well using all our nice colors. So here's my blue. We're going to do a t-table for the first one. Remember, we always start with what they give us. So in this situation, I have x is less than 0. So therefore, 0 is going to go here. And it can be less than. So I'm going to have an open circle. I write that on my graph so that I know when I graph it that I can consider that. And then numbers less than 0, remember, always go the right direction. Those are less than 0, and we can continue on. Okay, so let's plug in. If I plug a 0 in for 2x plus 3, I get 3. If I plug a -1 in, I get 1. If I plug a -2 in, I get -1. So those are my numbers I'm going to graph. I'm going to graph it in blue. So let's start with x is 0, y is 3, 1, 2, 3, open circle. -1, 1 is here. -2, -1 is there. I look at the function, it's a line. I'm going to connect it with a smooth line, and there we go. Blue piece done. Changing my color to red. I now need numbers between 0 and 2. Remember, you always take what they give us. Okay, because this is your focus on the limitations. And so I have 0, I have 1, and I have 2. Okay, 0, x can be greater than or equal to 0, therefore that is closed. And for x is less than 2 makes this open. Let's plug it in. If I plug in 0 in x squared plus 1, I get a 1. If I plug in 1, I get a 2. If I plug in 2, I get a 5. 1, 2, 5 are my numbers. Let's plot those in red. So here I go, 0 and 1, closed circle, 1 and 2, and then 2 and 5, 1, 2, 3, 4, 5, open circle. Look at your function. It's a parabola. It's a curve, so don't draw a straight line, okay, even if they want you to. Okay, so do it quicker so it doesn't take it as a straight line, because it's a curve. Okay, so that's a curve. It should look like half a parabola, so then you know you're good. Okay, let's do one more section, one more piece of the function. It's going to be using green. I need another little t-table. Okay, I'm going to start right here. And let's pick some numbers. X must be greater than 5, so I'm going to start with 5. Oops, sorry. 5, 6, and I can keep going, so I'm going to put an arrow there. And I see x has to be greater than 5, therefore this is closed. Nope. Okay, regardless of what the x values are, my y's are always 5. And let's plot this last piece. Okay, so 1, 3, 4, 5, and 5. 5. It's going to be open. And then this is going to be closed. And look at the pattern going this way continuously, so I have my arrowhead. Okay, that's my function. It's one function in 3 pieces, and now they ask us to find the domain of the entire function. Okay, so let's try to do the domain and the range. So doing domain first, I hop on here. I'm trying to move to the right. Okay, I'm okay there. Oop, hole, but wait, filled in. I can still go. Okay, oops, stopping right here. Then I'm going to jump across and start again and go for it. So I'm going to have 2 pieces to my domain. So following that pattern, I started at negative infinity. I ended up going to 2 with an open circle, so I couldn't equal it. Then I jumped across to, what was that? 2, 3, 4, 5. Also can't equal that. And then I go all the way to infinity. That's a 2-piece domain connected by the U for union. Okay, let's try to think about the range. I'm going up here. I'm on my function already because the arrow went all the way down. So I'm trying to climb up this time. Up, go up. Up, gotta come down. Okay, I can go up again. I can't go any further, but could I have this value? Yes, I can, but that's the highest y I can get to. So let's do our range. I started at negative infinity, and I went all the way to 5, and I could equal it, but I couldn't go any further. Okay? So let's see what else we have to do. I have a couple of more. I think I have 3 more of these piecewise functions, so stick with me. Okay, so let's look at this next one. This is an H function, and it says to evaluate and then to graph it. So we can do this pretty quickly. And since you're doing it on a video, whenever you want to stop it, you can, and then listen, see if you can figure it out, and then turn it back on again. Because if you just listen to it all the way through, I'm afraid it's going to be very confusing. Okay, so where can we evaluate the function if h is 0? We're going to use the green. If h is 3, if x is 0 and x is 3, we're going to use the green. And then I'm going to change to red. This only has 2 pieces. And that will be what I would do if I was trying to find h of 8. Okay, so we need 2 t-tables. And actually, they started doing them for us down here. So we're in pretty good shape. Because look what they've done. Notice that these are the endpoints, and those are the endpoints of my x numbers I've selected to evaluate. You definitely want to do that. Now I'm going to write in closed here and closed here because of the less than or equal to signs. Okay, that's open, but at 7, it's closed. So I like to write both open and closed. Some people just write open and then anything else, they assume it is closed. But I like to do both because I like to think it through. Okay, so we have closed, closed, closed. So I shouldn't have maybe used that color, but that's okay. I'll change back. Okay, so they gave us x and y values for the green function. Okay, so I will say that this whole thing is the green function. These are green values, green domain. So now let's do it for the red function. So this is my red function. There I have it. They gave me these x's because remember what I'm doing is I'm grabbing what they give us to work with. Got to use those same ones. And now let's evaluate them. So plugging in 3 to the function should get me back a 5. Plugging in 4 got me an 8. Plugging in 5 got me a 9. Plugging in 6 got me an 8. Plugging in 7 got me a 5. So see how you find that. You can check my math, but I think I'm okay. Oh, let me do the evaluation up here. If you put 8 into the function, you've got to use the second piece of it. And it has to be, x has to be less than or equal to 8. So this is a no value. The function is not located there. So I cannot get a value there. H of 3 takes me back to the green function. You plug in a 3, you're going to get negative 3 plus 8, which is going to be a 5. If you plug in a 0, you'll get 8. Okay, so that's what you should be getting up there. And now let's graph it. So we only have 2 pieces to graph. So I have the green first. So I'm going to do the 0, 8. So 1, 2, 3, 4, 5, 6, 7, 8, closed circle. 1, 7, 2, 6, and 3, 5. And that's closed as well. So no arrowheads here. You only have this piece. Okay, so then we go down to the red function. That is a parabola, so I have to have a curvy shape. So at 3, 5, I have an open. So 1, 2, 3, 1, 2, 3, 4, 5. Put an open around here because that was closed by the previous function. Okay, so that's 3, 5, and then I need 4, 8. So that's 5, 6, 7, 8. And then I need 5, 9. So that's 8, 9. And then I need 6 back to 8. And 7 back to 5. Okay, so you can see I can capture the curve of the parabola. So don't connect those with straight lines. Okay, and the parabola is going to end there, so I have no arrowheads either. Changing to black, I'm going to do the domain of the entire function. So my function in terms of the x's, I start here at this x, which is 0. I can go all the way here. Those are all good, and I have to stop here at this x because that's as far as I can go, and that x was 7. So that means that my domain is going to be with brackets because I can equal these terms, 0 to 7 bracket. Okay, let's look at the range. The lowest number I can get to is this one right here. So I'm going to start at 5, and then the highest one I can get to is this right here, which is 9. I can equal both of those. So my range is 5, 9. Now, one thing you should notice, your piecewise functions never should cross each other. They have to pass the vertical line test. So that means when you take a vertical line and you draw it up and down, you should only be hitting this piecewise function one place. Because see, right here, you're not hitting in 2 places because you have an open circle and a closed circle. So you only hit where it's closed. Other than that, your function should not have any kind of overlap. Otherwise, it's not a function. And we're telling you they are functions. Okay, so let's do this next one, number 4. And this one has 3 pieces. The middle piece is a parabola. So let's see if we can get that done. So I'm going to change the colors again. So go green first. So this is green. It has to be less than 2. So nothing works, less than negative 2. Nothing works there in the evaluate box. We'll go with red again. And then for red, it's going to be here. And that works here. And then for green, it's going to be here. Well, here, I think I should do blue. For blue, it's going to be here. And that will work there. So let's go ahead and evaluate. I really just need, oh, sorry, I should have done this in red too. So if x is a negative 2, then y equals x. So that's also going to be a negative 2. Hold on. I'm reading the wrong thing. I want to read the middle one because I can't use it because x has to be less than negative 2, not equal to it. So use the red function and plug in a negative 2, and you should be getting a negative 5 back. 0 also falls in that middle function. Plug in a 0, and you should be getting a 3 back. Then you've got to switch to the bottom piece of the function, plug in a 5, and you're always going to get a 3 back because that's what the y value always is, regardless of what the x value is. Okay, so we've done that evaluation. They've set up some of your graph here, your t-table. So I'm going to just add to it with the right colors. So this line is our green. And if x is less than negative 2, so that means that it is open here, but everywhere else is closed, and it goes forever and ever. So I'm going to indicate that there. So this is always going to be equal to itself. Okay, so that's what I'm getting there. Okay, now keep going, and I'm going to the next piece, which is red. And this is the parabola. And notice that they put in our starting and ending points. And I would just write that this is closed here and closed here. And you should get the following values: negative 5, 0, 3, 5 again. Okay, that's your parabola. And then let's do the last piece, which is my blue piece. And that's a line, it's a horizontal line. Notice it's going to be open right here. And open is written there. And I'm going to have a 3. Wherever I have any x values, my y will always be 3. And I'm going to put my arrow right here. Okay, so notice we're stressing having the arrows in so you know where to put arrows on your function. So let's graph our function. So looking at the top, x is a line. So I'm going to plot negative 4, 4. So negative 4 should be there and it's closed. And then I have negative 3, 3. There. And then I have negative 2, 2. But that's going to be open. Okay, so I see the pattern heading this way, and I know I have an arrow going that way. Okay, let's get to the middle section in red. And I see that I have the following points to plot. So I have a negative 2, negative 5. So negative 2, negative 5. 1, 2, 3, 4, 5. And that's going to be a closed circle. So where the other was open, above it, this is closed. So that's my first point there. Then I'm going to go to my negative 1, 0. So negative 1, 0. That's also closed. 0, 3. And then 1, 0 back down here. And then to negative 5. And that's also closed. So you can see the parabolic shape. So don't draw it as a straight line, draw it as smooth curve, and then you have the second piece. And then the last piece will be in blue. And this has to be where x is greater than 2. So the points are 2, 3. So 1, 2, and then up 3, 1, 2, 3. And that's going to be open. And then everything is going to be 3 after that, and it's going to go on forever and ever. So I'm going to go this way. Okay, so let's think about that. So this is 2, 3, 1, 2, 3. And that was 0, 3. So I think I need to make one correction, and that's right over here. That should have been 0, 3. So let me fix that. So if you caught that while I was doing it, that was good. Now that's correct. So I'm good to go. Okay, so now let's figure out the domain and the range. So we're looking at the entire function, and we're going to go piece by piece. So let's talk about domain. I'm on my x here. I want to travel to the right. Okay, so I'm blocked here. Oh, I can dive down here, and I can keep going to the right. Okay, I can come down here. I'm still going to the right. And now I can hop back up here and continue to the right. So therefore, there's no x values that I cannot equal. So negative infinity to infinity are my x values. Let's look at the y's now. So starting down here, my goal is to go north. So I get to here, I have to go down to go up. I had to go down again. I'm still trying to get up. So I can go up and get on this path, but I cannot go any higher. So this is the highest value I have for my y value, and that's a 3. So that means that I had no gaps in between, but I cannot go beyond 3, but I can equal 3. Thus the bracket. Okay? We have one last one to do, and then we're done. So here I have it. We're looking at these two pieces. Okay, so this is an absolute value piece. So you have to remember what absolute value is. It means that whatever is inside, you take the sign off when you pull it out. Okay, so we hadn't really gone over that, but I want to mention that to you right now. Okay, so let's do just two colors. The top one is green, and that's going to work for these two pieces. And then we'll do red on the bottom, and that's going to work for evaluating this. So let's go back to the green and say plug in a 1 in the top function, and you should get a positive 5. Plug in a 2 in the top function, and you should get a positive 4. And then let's change to red and plug in a 3 in the bottom function. Okay, 3 minus 4 is a negative 1, but then you take the absolute value of it, so that's 1, but then you negate it, so that's back to being negative 1, and negative 1 plus 3 gives you a 2. So hopefully you're comfortable with absolute value. They have done most of this for us. I will also add the word closed here. And let's figure out my y's. So you should do this yourself. I'm going to get my green color. If I plug in an x into the function, I should get the following y values. Just check my math to make sure that it's good. Let's change to red for the bottom function. And I'm going to plug in 2, 3, and 4 into this absolute value function. And I'm going to get 1, 2, and 3 back. Make sure that you can get those. If not, ask me. And that's it. Now we have to just graph those two pieces. So the green piece will get graphed first. The green piece is open at x is 0, y is 6. 1, 2, 3, 4, 5, 6. I have a big old open circle there. This is a line. I'm going to watch the pattern. And I'm going to stop right here. So I only have this little piece. Okay, no arrowhead there. And then I'm going to change to red. And I have an open and a closed situation going on. Actually, I have two open situations going on. So at 2, 1, so x is 2, 1, I have an open circle. This is an absolute value function, so it's going to be part of a v. At 3, 2, I have a filled in dot. And at 4, 3, I have another open. So this is what that piece looks like, and that's all there is to that piecewise function. Let's change to black, and we'll figure out domain and range of the entire function. Turning on my little light, I try to get on the furthest x to the left, and that's going to be 0. I stay on x's. I can stay on. up, but I can't equal this one. So my furthest part from my x, which is x is 4, has to be a paren and not a bracket. The first one has to be a paren also, so 0, 4, both parens. Let's talk about our range. The lowest value I can get to on y is going to be at positive 1, and that is going to be a paren. So I'm going to make a paren. I come up to positive 3, and I get stopped. I can't cross. So I'm going to stop at 3, and I can't equal that, so I have a paren. Then I'm going to jump across. So I was here. I'm going to jump here to 4. Oh, I can equal 4. That's a closed circle. So that means I'm going to say union with 4, comma. I want to keep heading north for my y values. And I can get up to here, which is 6. That's the highest I can get to, but I can't actually equal it. And because that is the situation, I have 6 with a paren. And we are done. Okay, so those are the notes. I was very systematic. You need to be systematic. You see, none of my functions cross. If you're doing your homework sheet and things are crossing, something is wrong. All right, so if you need to go back over this and kind of get a better handle on it, that's fine. But this is the lesson for today, and now you're set to be able to do the homework.